Being able to perform mole conversions will prove to be one of the most important skills you'll learn in chemistry. Therefore, this video is geared towards giving you some practice problems with some simple mole conversions that you'll come across. On the screen right now is a helpful guide that you can use to perform mole conversions. While everything in this video will be set up in a dimensional analysis setup, you can always use this helpful guide to help you do mole conversions. Notice that the mole is in the center, and then units are on the outside depending on what the problem might be asking you to convert from or convert to. In this video, we're going to solely look at particles and grams. We're not going to look so much at volume because that will come later when we talk about gases. Notice that there is no direct path between grams and particles. If you're asked to convert from one to the other, you have to go through the mole first. Notice the math operation. Whenever you want to go from moles to an outer unit, such as a particle or a gram, you have to multiply. Suppose you want to convert to the mole in the center. Notice how you have to divide. And the conversion factors that you'll multiply or divide by are given on the side. Just a quick note before we move on to our practice problems. The Avogadro's number that's listed here is a little bit simplified. It's 3 significant figures. We will do our conversions to 4 significant figures. So make sure you're using Avogadro's number as 6.022. All right, with that being said, let's get to the conversions. The problem is giving us information in grams, and we are asked to go to molecules, which is classified as a particle. We can't go directly from one to the other, so we're going to have to go from grams and convert to moles, and then once we're in moles, we can then convert to molecules. That being said, let's go ahead and set up our problem. All right, here is problem number 1. The first question says, how many molecules of magnesium chloride, MgCl2, are there in 67.35 grams of magnesium chloride? It's important to note, just like every dimensional analysis problem, note what you're currently in and what you want to get to. The number that's being given to us is in grams, and we would want to get to how many molecules of MgCl2. So if we look back at our helpful guide, we can see what kind of pathway we have to go through. All right, the first thing I'm going to do is I'm going to start out with what the problem gives me, which is 67.35 grams. All right, now since I need to get to moles first, that will be my first conversion factor. Grams will go on the bottom and moles will go on top. This is where I'm going to use the molar mass. For every 1 mole of magnesium chloride, it is going to have a certain mass. The molar mass of magnesium chloride, or MgCl2, is 95.21 grams per mole. This will make the gram units cancel out, and therefore I'm in moles. The next conversion now is to go from moles to particles. Moles goes on the bottom, and particles, which is molecules in this case, goes on top. For every 1 mole, this is where we will use Avogadro's number, 6.022 times 10 to the 23rd. The moles cancel out, and when I calculate through, this is going to give me my answer. When I calculate through with correct number of significant figures, my answer would be 4.260 times 10 to the 23rd molecules. And let me just write MgCl2. So that is my correct answer for this problem. A couple things I want to note before we move on. First of all, I got 4 significant figures in my answer. The only place I got that from is the 67.35. 95.21 also has 4 significant figures, but recall, we always round our molar masses to 4 significant figures just to keep our problem simple. The reality is we could have been more specific with our molar mass, but 4 significant figures is plenty good for this level. Also, Avogadro's number is similar. It could go out further, but we round it to 4 significant figures to make our calculations easier. So therefore, we're never going to base significant figures off of molar mass or Avogadro's number. And therefore, 4 significant figures from the given quantity is the only value that will limit our sig figs. All right, now there's a follow-up question at the very bottom. It says how many chlorine atoms are there in the same mass of magnesium chloride? All right, I've given myself some space here to solve the second problem. The second problem is actually very simple, but in order to understand it, we need to take a look at a practical or concrete example of what's going on here. So let me ask you a question. Let's say you had exactly 1 molecule of MgCl2. Not 1 mole, 1 individual molecule of MgCl2. For every 1 individual molecule of MgCl2, how many atoms of chlorine would you have? Because chlorine has the subscript of 2, that means it would have 2 atoms of chlorine. Okay, what if I said you had 2 molecules of MgCl2, 2 individual molecules in space? Because every molecule has 2 atoms of chlorine, if you had 2 molecules of MgCl2, you're going to have 4 chlorine atoms. Let's look at it one more time. Suppose I said you had 10 molecules of MgCl2, 10 individual molecules in space. How many chlorine atoms would you have? The answer would be 20. So notice in all of these simple examples, you always have double the amount of chlorine as you do the molecules. When you had 1 molecule, you had 2 chlorine atoms, and when you had 10 molecules, you had 20. You're always going to have twice as much. So instead of having 1, 2, or 10 individual molecules, you just happen to have a lot of them. But the concept is still the same. For however many molecules of MgCl2 you have, you're always going to have double the amount of chlorine atoms. So therefore, to answer the second question, how many chlorine atoms are there in the same mass of magnesium chloride, we pick up where we left off on the problem before. We know we're going to have 4.260 times 10 to the 23rd molecules of MgCl2. And we know that for every 1 molecule of MgCl2, it will contain 2 atoms of chlorine. Therefore, all we have to do is multiply our answer by 2 from before to get our answer to the second problem. And so our answer to the second problem with 4 significant figures would be 8.520 times 10 to the 23rd chlorine atoms.